Hello everyone, we are going to start introduction of physics which is required in entrance examination NEET and JEE. Physics for NEET examination and JEE examination. So first of all, what is NEET examination, which is National Eligibility Entrance Test, and JEE is Joint Entrance Joint Entrance Examination. So we know that National Eligibility Entrance Test, that is NEET, is conducted in the month of May every year, and JEE is conducted in the month of January and April. So if you want to make career in engineering, so you have to apply for BTech program in various engineering colleges in India. So we call that program as BTech. It is BTech program. So earlier it was known as BE, that is Bachelor of Engineering. But in recent years, people have been calling it as BTech. So the name is changed from Bachelor of Engineering to Bachelor of Technology. So it is more wider. When I say engineering, so normally when we think about engineering, we think about bridges, uh, roads, construction. But when computers came and IT, information and technology revolution happened, and the data science evolved, and networking, I'm talking about data networking, the age of internet evolved. So we started calling all these technologies. So the engineering and technology we can combine. So then the common name given to that course is now BTech. So that is Bachelor of Technology. So the topmost institutions, that is IITs. So that is IIT, Indian Institute of Technology. So we have in India, that is the premier colleges, that is government funded. Central government is giving funding for them. So they have a huge sprawling campus with them, and every year a single IIT take intake of around 500 students in their first year BTech program. So so it is a two-level examination. So first, to get into IIT, you have to first you have to clear this joint entrance examination, which is a multiple choice questions. So around 25 MCQs are there per subject. Then then you have to clear advanced level test also, that is conducted in the month of May. So we call it JEE advanced, correct? So this is known as JEE mains. So mains is conducted in January and advance is conducted in month of May. So you have to clear mains as well as advanced to get into IIT, and to get into NITs and other engineering colleges you have to clear JEE mains. You have to qualify JEE mains. So to become a good engineer, I would rather say to become a good engineer, we should aim for doing B Tech from IIT, to become good software engineers, to become a good programmer. So we should always try for IIT, that is to clear JEE main as well as JEE advanced. Some students think to become engineering, why we have to study JEE, why we have to study, why we have to prepare for JEE. Then actually engineering needs a wider uh, understanding of core subjects, which is physics, chemistry, and mathematics. The mathematics will use a brain, your mind. So the calculations, how much your mind can think, up to what level your mind can think of, right? So mathematics is like that, and physics is how much you are observing your surrounding, how much well you are observing, you are aware of your surrounding. Like for example, the space, how much you are aware about space, how much you are aware about your climate. So that is about physics. So how you can use the concepts of physics to invent something new for the betterment of human civilization. And chemistry is another subject which is deal with which we deal with for the microscopic studies, like for example electrons, neutrons, protons, chemical reactions of various compounds. So all these three subjects are core subjects for the engineering. Like for example, to construct a road, what material is used in a road, so chemistry is involved in that. What should be the banking, angle of banking in that road, that is physics is involved in that. So when we say angle of banking, so angle is involved in that. So maths is also involved in that, correct? So to construct a road, what should be the curvature, what should be the radius, so maths is involved, physics is involved, and chemistry is involved when we construct a good quality road. Now let's talk about NEET. Now as a human civilization, we know about diseases, we know about some treatments also. So but it is continuously evolving. So as more and more knowledge we are gathering about viruses, bacteria, so more we are aware about it now. So more doctors are required in India. So currently around the ratio is one doctor in around 900 population. So for 900 Indian population, one doctor is present. So this, as compared to whole world, like global ranking, it is considered as good. But in India, still it is less. So we actually we need more doctors for our future generation. Like for example, in next 50 years at least, more doctors are required. So that's why the government is planning to construct new medical colleges also, so that the number of doctors should be uh, should not be less. It should be around maybe for 500 population, maybe one doctor is there, but that is not easy to make. Maybe for 800 population, one doctor is there. So this ratio 900 divided by 1, so this ratio should decrease. So it can be 800 population and one doctor. So this ratio should decrease. So as we are aware of the COVID situation also, during COVID times, the doctors were less and patients were in high numbers, right? So if the number of doctors are more, so the treatment will also be better. So more doctors are needed, more medical colleges are there, should be there, and more they will construct in the future. So now, what it takes to become a doctor, we have to prepare for entrance examination, that is NEET, which is National Eligibility Entrance Test. Now let's take one example of something related to medical treatment or doctor. Let's take example of X-ray. Imagine 100 years back, that is 18th century. Let's talk about 18th century or 19th century. If someone is falling so from the building, suppose first floor to ground floor, someone is falling, so the pain will start in the leg, and that pain will last for many days, and the person is not aware of what is going on, what has happened, correct? And that person is in great pain. So imagine now we have this treatment, this diagnosis, that X-ray. So if a person is suffering from falling, something happened to the body, so we can check if there is fracture in the bones. We can detect fracture in the bone. Even the smallest fracture, if it is there, the X-ray machine can detect it. So we are using concepts of physics, right, in X-ray. Then suppose some tablets are there, so the knowledge of chemistry is needed to to uh, to make the medicines, the syrups, and to make the fluids, the intravenous fluids, and then definitely the concept of biology is needed, because the human body is full of biological activities, how brain works, how blood is flowing, how heart is supplying blood to whole body, how tissues are working. So the concepts of biology is there, and concepts of physics is there, and the concepts of chemistry is there. What medicine, how much milligram of particular compound is needed in that medicine, correct? So these core subjects are needed: physics, chemistry, and biology. These core subjects are needed. Now, so what is common in both? In NEET and JEE, the common subjects are physics and chemistry. These are the common subjects. So let's talk about physics. Let's talk about physics. So as a student, when we are preparing for these examinations, JEE or NEET, first of all, we have to understand we are learning something. We are learning something. We are learning something, as well as we have to crack an examination. So there is a competition in that. We have to learn, as well as we have to be ready for the competition, because these examinations, NEET and JEE, these are called as competitive examinations, because a large number of candidates are writing these examinations every year. Large number of applicants or candidates, large number of applicants or candidates are applying for it. and the seats are limited. Suppose, for example, 2 lakh seats are there in engineering, and 15 lakh students are writing this examination. So, how do they select the students, the candidates for the seat? So, there is a concept of percentile. There is a concept of percentile that we can discuss in some other time, but roughly we can say, suppose the percentile is 99. So, the student is in top 1%. If the percentile is 98, so the student is in top 2%. So nowadays the joint entrance examination committee is not posting marks, how much marks the student got, but they are publishing how much percentile they have got. So directly they want to tell us that it is a competitive examination, not a subject examination. So normally in our school we have subject examination. For example, 10 questions are there. Question number 1 2 marks, question number 2 also 2 marks, 3 and 4 are 3 marks, like that. So there's maybe some derivations, some numerical problems are there, so you have to solve that, you have to answer those questions, and finally you will get some marks. So the marks will tell you how much you learn and how much you know, how much you can apply your learning. So that is purely based on learning. But now in this competitive examination, you are well above how many other students. That is a deciding, that we are going to decide using these examinations, correct? Like suppose you are in top 10, or you are in top 100, or you are in top 1000, or you are in top 1 lakh, or you are in top 2 lakhs. So we have to be in top, we have to be in top. Maybe you are in top 1 lakh, top 10,000, top 1000, top 100, top 10, or top 5. So that is a competition. So when it comes to competition, uh, the syllabus is fixed. How much we have to study, the topics, the number of chapters are fixed. But the number of questions are not limited. You have to solve variety of questions from variety of study materials. So it is unlimited. The concepts, topics, and number of chapters that are limited, but the types of questions, the types of MCQs are unlimited. So we can never say that our preparation is completed. We have to keep trying. We have to keep solving new questions, new exercises, new MCQs, different varieties of questions to handle this competition, because you have to be in the top 1 lakh, or top 10,000, or top 1000, or top 100, or top 10, or top 5. At the same time, learning should be there. So some candidates, some students focus on competition, and some students focus on learning. Both have meanings, and both have importance also, because to make a career in engineering, you have to get a BTech from good IIT, well reputed engineering colleges. Then after colleges also placements are there, so in that also competitions are there. So the competitive spirit should be there, but at the same time, how much you know in during the placement, the interviewer will ask questions, what is the string, what is the data structure, what is a stack, what is a linked list. So how much you have learned in your computer science engineering. So they can ask any question, so you have to answer those questions. So it is better to go parallel with them. So you are learning at the same time, and you are preparing for a competition examination at the same time. So learning physics, let's start with learning physics. And regarding competition, it is a test. The test skills, test what skills are needed in test, that we will discuss separately. So what is required to learn physics? So you, first of all, the student should be able to observe surrounding. Student should be able to observe your surrounding to start with. So physics is all about your observation. What you see in your surrounding. For example, suppose you are in a house. You are in a house. So what you see? You see a ceiling fan. Maybe there is a ceiling fan, and maybe there is a TV. There is a TV fitted with the wall. So there is a physics in these two objects. What type of physics is there? You can think of like why this fan is not falling. It is not falling. Why this fan is not falling? Then you can start thinking like this: the weight is pulling it down. The force weight is pulling it down. So because of this gravitational pull from Earth, the ceiling fan should fall, but it is not falling. It is not falling. So something is stopping it from falling. Like for example, if you release this object, it is falling, but now I am holding it. Now I am holding it, so it is not falling. So that means Earth is pulling it down, so it should fall, but it is not falling. So that means something is pulling it up also. If Earth is pulling it down, so something is pulling it up also. So that is my hand. My hand is holding this pen, so my hand is pulling this pen upward. So that is the force. Pull force. If I release my force, the pen will fall. So now when it is falling, only gravitational force is acting. My force is not there now. When my force is not there, it is falling. When my force is also there, it is not falling. So that is physics. So there is a concept of balanced forces. So there is a concept of balanced forces. Similarly, suppose this is the TV set. So clamps are there. Clamps are there. So they support the hanging objects. Clamps support hanging objects. Clamps support hanging objects. Anything which is hanging, so it must be supported by something. That something is known as clamp. So suppose I am holding this pen like this. So these two fingers are acting as clamps. So sometimes the clamp look like this. It is like a hook. So we can call it clamps. Or you have simple nail, a nail and a ring. So you can put a ring over the nail, and that ring is holding the object. So that ring becomes clamp. So this is the concept of balanced forces that you can see in your house. Now let's observing some more events. Anything which you can observe, something is going on in your surrounding, that we can call it events. That we can call it events. So if that event is occurring because of natural phenomena, so we can call it natural events. Let's talk about cloud formation. Let's talk about cloud formation. If you go out of your house, you see the clouds are forming, right? So clouds are basically are basically water droplets. These are basically water droplets. Very small water droplets are there. So water droplets are in motion. They are in motion because when temperature is changing, so water will convert into gas, liquid will convert into gas, we call it steam. So that steam is rising because it is lighter, so it has more speed, temperature is more, so it has more speed, so they rise, they go in some height. But gravity is also acting, so because of temperature they are rising, the water molecules, water droplets are rising, but at the same time the gravity is acting down, gravity is pulling it. So at one point they come to stationary, they are stationary because they cannot go further up, and gravity is also pulling it. So at that height they settle, so water droplets are settled, but still they are moving, they are moving horizontally, sometimes they are moving vertically, so they are colliding. So the water droplets are colliding, water droplets are colliding. So because of that, what happens, suppose one water molecule is there, H2O, suppose this is the water molecule, so another water molecule is there. So one water molecule may transfer electron to other water molecule. One water molecule may transfer electron to other water molecule. So as we know that electron is negatively charged particle. So when one water molecule is losing electron, that one water molecule will get positive charge because it is losing electron. So number of electrons are less. So there is a deficiency of electron. So when there is a deficiency of electron, we call it as positively charged object. Now similarly, another water molecule is gaining electron. So there will be excess. There will be excess of electron. There will be excess of electron for one water molecule. There is deficiency of electron for other water molecule. There is excess of electron. So we say that one water molecule gets positively charged, another water molecule gets negatively charged. But you see in the cloud, these clouds are huge. So the number of water molecules are tremendous. Very large number of water molecules are there. Billions, trillions of water molecules are there. So you imagine we have one cloud which is full of positively charged water molecules, and we have another cloud which is full of negatively charged water molecules. So what happens, there is a natural phenomena which says that the positive and negative attract, positive and negative attract, and positive and negative charges attract, and sometimes the negative charges are attracted to ground also. The ground is said to be neutral, ground is said to be neutral, so these negatively charged cloud is attracted to ground also, and positively charged cloud is also attracted to ground. So this negatively charged cloud is attracted to ground. So what happens, the electrons are transferred to the ground. Electrons are transferred to the ground. But when a positively charged object is attracted to a ground, then we say the electrons are transferred from ground to positively charged cloud. So this phenomena is known as lightning. This is known as lightning. This is known as lightning. So basically, it is just a transfer of electrons from one charged body to another charged body. Like negatively negatively charged body has excess of electrons, positively charged body has deficiency of electrons. So the electrons will be transferred from one body to another body. And ground is a neutral, earth is a neutral. So the charges can be given to ground. So like for example, negative cloud is there, so electrons will be transferred to ground. If positive cloud is there, so electrons will be transferred from ground to cloud. But for that, one more condition should be there. The earth should be conducting. Sorry, the air should be conducting. Air should be conducting. When this happens, when air is conducting, then only it happens. Conducting means the dry air is non-conducting, but when you add moisture in air, so that air becomes conducting, because when moisture is there, so it can transfer the electron from one molecule to another molecule, so there will be flow of electrons. And the gas will be ionized. So conducting air is also known as ionized gases. Air is conducting means this is also known as ionized gases. When gases are ionized, the gases becomes conducting, means some electrons are removed from a molecule of a gas, or electron is added to the molecule of a gas, so they becomes ionized, so the air becomes conducting, so electrons can be transferred from positive to negative cloud, or negative cloud to ground, or ground to positive cloud. So that is known as lightning. So normally we observe it, so that is physics is involved. So that is also the core concept of our lecture today, which is electrostatics. So this is one of the example of electrostatic that we observe in our daily life, that is lightning. So let's start the topic, electrostatics. It is the class 12th topic, class 12th topic. It is the class 12th topic. So as the name is saying, electro, let's break up this name of the topic, electrostatics. So when we say statics, so immediately the meaning of statics means the picture of something which is at rest. Something which is at rest will come in your mind. Statics, static. Rest means static. Like for example, suppose if you are sitting in a room, you see the table is there, so table is at rest. The door may be at rest, or some wall paintings are there, so they may be at rest. The bulb, LED bulb is there, so that may be at rest. So something which is at rest continuously, rest continuously, something which is at rest continuously, and you are observing it, you are studying it, Why it is at rest continuously? For example, you place a cup of coffee in your table, and that cup of coffee is at rest, it is not falling down. So why it is at rest? Suppose there is a cup of coffee, and the cup is not falling down, so why it is at rest? You are asking yourself why it is at rest. So you will say the weight is mg, which is acting downward, the normal force is acting upward, then the forces are balanced, so that's why it is at rest continuously, correct? So study of objects which are at rest are known as statics. So like for example, in mechanics generally we deal with particles, like a ball is held by a person, then ball is released by a person. When the ball is held by a person, you see the forces are balanced, but when the ball is released from the hand of a person, so force becomes unbalanced. Unbalanced force causes acceleration, and when forces are balanced, acceleration is zero. So statics is the branch of mechanics in which the object is at rest. Then we study about fluid statics also. Fluid statics. In fluid statics, we study water molecules or air molecules, because a fluid is a common name given to both liquid and gas. So this fluid statics, we study fluid at rest, fluid molecules at rest. Like for example, you put water in a container, and that container is kept on the table. So the water molecules are at rest. But the same water, when it is flowing through the pipe, then it is not at rest. The water molecules are in motion, they are moving. When water molecules are in motion, then if you are studying that water molecules, so then we call it fluid in motion. Fluid in motion. You are studying fluid in motion, and why it is in motion? Why water molecules are in motion? Something is pushing water molecules to flow, that is pressure. So when pressure difference is there, the water molecules flow, correct? So that is fluid in motion. So that is known as fluid dynamics. Fluid dynamics. So something which is at rest, and you are observing it, you are studying it, so we can call it statics. So here also we have electrostatics. So what is that? What is electrostatics? So the quantity we are going to learn is charge. What is charge? What is charged body? What is charged body? And what is charged particle? Charged particle. What do you mean by charge? What do you mean by charged body? What do you mean by charged particle? So what is a charge? What is a charge? We can say a property. Charge is a property of body due to which it can produce electric field around it. It can produce electric field around it. So charge is a property of a body. It can be a particle also. Property of a body or particle. Now creating electric field means what? What do you mean by creating electric field around itself? Let's understand it by taking example of gravitation. So suppose if I say this is earth, This is Earth, this is Moon. So we say the Earth is attracting Moon, and Moon is also attracting Earth. So Earth is exerting pull force on Moon, and Moon is exerting pull force on Earth, because the Earth has produced gravitational field around it. Earth has produced gravitational field around it. Earth has produced gravitational field around it. So if any mass object is in that field, like for example moon is near Earth, so we can say the moon is in the gravitational field of Earth, or moon is inside gravitational field of Earth. So moon will experience gravitational force because of Earth, and similarly Earth is inside gravitational field of moon, so Earth will experience gravitational force because of moon. So the force and field, if there is a field, so there is a force. If there is a force, that means there is a field. So now Earth has mass. So the mass produces gravitational field. So the charge produces electric field. Something which can produce electric field in the surrounding or near it, we can call it a charge. There is a charge. It can be charged body, it can be charged particle, it can be metal, it can be non-metal, it can be of any shape, it can be spherical body, it can be a linear object like a rod, it can be a ring shaped object, it can be big object, it can be small object. For example, water molecule is a small charged body. Water molecule is a small charged body. But if you say cloud, when you consider a whole cloud is a big charged body. So something which can produce electric field around itself is known as charge. Now let's talk about electron and proton. Electron and proton, and one more particle is there, neutron. What are these particles? So these are the particles. These are the particles. Some people call it elementary particles. Elementary particles. So these are particles means what they have? They have mass. Particles means they have mass. So matter, they are made up of matter. They have mass. So let's write their masses first of all. So the mass of electron is 9.1 9.1 into 10 raised to minus 31 kg, and the mass of proton is 1.67 into 10 raised to minus 27 kg, and proton is also same, almost same as that of proton. Neutron is almost the mass is same as proton. So this is in kg. This is in kg. But to understand the difference of masses, we have one more unit to denote the mass, we know that it is 1 AMU, that is known as atomic mass unit. Atomic mass unit. So 1 atomic mass unit is 1.67. Some books write it as 1.66. So 1.67 into 10 raised to minus 27 kg. In short, you can just remember atomic mass unit as 1 by 12 times the mass of carbon atom whose mass number is 12, whose mass number is 12. So that is known as atomic mass unit. So in atomic mass unit, the masses are like this. The electron is 0.00057 AMU and proton is 1.0074 AMU and neutron mass is 1.0086 AMU. So the mass of proton is very large as compared to mass of electron. The mass of proton is around 1827 times the mass of electrons times mass of electron. So electron is heavier as compared to electron, almost 1827 mass of electron into 1827, that is equal to mass of proton. But the neutron mass is slightly greater than proton. So almost equal. Sometimes we can consider both are equal also, but practically slightly it is greater. Neutron is slightly greater. So that is about mass. So these are particles. So these are elementary particles. What else they have? They have mass and they are very small in size as compared to the size of human being. So these are microscopic particles. Another property they have is the charge. Electron has charge, proton also has charge, but neutron don't have charge. So neutron is neutral. Something which don't have charge is known as neutral. But electron and proton have charge. The nature of charge on electron and proton are opposite. Nature means the nature of field. Nature of field. Let's suppose we have an electron here. Let's suppose we have an electron. This is an electron and there is some positively charged body. So this electron will attract this positively charged body. And suppose we have proton. Suppose we have proton and the same positive charge is there, so proton will repel this positively charged body. So electron will attract this object, but proton will repel this object. So that means electron and proton have opposite nature. Nature in the sense of interaction, how they are interacting with other charged body. Like this is positively charged, so this is a electron, so it will attract it, but proton and positive charge will repel it. So proton is pushing it away and electron is pulling it away. So they have opposite nature. They have opposite nature, but the magnitude will be same. How much force electron is exerting on this charged body is same as how much force the proton is exerting on this charged body. So the magnitude of force is same, but directions are different. So electron is attracting it with a force F, and proton is repelling it or pushing it with a force F. So magnitudes of these forces are same, but the directions are different. This electron is attracting positively charged object, proton is repelling this positively charged object. So they have opposite nature. They have opposite nature. So, but the charge is same. Magnitude of charge is same. So scientists and researchers have considered that the charge on electron is said to be negative. Charge on electron should be said to be negative, and charge on proton is said to be positive. Just because they have opposite nature. So one is called as negatively charged particle, other is called as positively charged particle. And the third particle, neutron, has no effect like electron and proton. So suppose neutron is there and one positively charged body is there. So neutron and positive charged body has no interaction. So neutron cannot attract or pull. So that's why we call it neutral. So that is one understanding of difference between electron and proton. But we are studying charged body. So what do you mean by charged body? So let's talk about atom. So we have a nucleus. We have a nucleus, and inside nucleus we have protons and neutrons. So the number of protons is Z. This is known as atomic number. This is known as atomic number, and the number of neutrons is A minus Z. A minus Z. Now here A is known as mass number. A is known as mass number. For example, let's take oxygen. Oxygen atom. So the mass number is 16 and the atomic number is 8. So that means it has 8 protons. 8 protons inside the nucleus. So how many neutrons are there? 16 minus 8. 16 is the mass number, 8 is the atomic number. So 16 minus 8, that is equal to 8. So 8 neutrons. So oxygen atom has 8 neutrons. 8 neutrons. As we were discussing, protons are positively charged. So the nucleus is positively charged. Nucleus is positively charged. Nucleus is positively charged because it has protons. It has protons. So nucleus is positively charged. What about atom? Atom is neutral. Atom is neutral, but nucleus is positively charged. How come is it possible? So atom, when we talk about atom, we have to consider what is inside atom. So when you consider atom, the what is inside atom? It is a nucleus which is neutral. Sorry, it is a nucleus which is positively charged, and it is surrounded by electrons. These are the electrons. So this is how we denote electrons. You write the symbol E and put the minus sign above it. So nucleus is surrounded by electrons. So electrons are negatively charged particles, and we know that the charge on electron and charge on proton, they are same but opposite in nature. So electrons are negatively charged, protons are positively charged, correct? So that means the number of electrons must be equal to number of protons. Then only we can say the atom is neutral. So this is known as neutral body. Suppose number of electron exceeds number of protons. Number of electrons are more. So that means electrons are in excess. Electrons are in excess. Electrons are in excess. So we will say the atom becomes negatively charged. So this is known as negatively charged body or negatively charged atom. Similarly, if a number of proton is greater than number of electron, so we say that it is positively charged body or atom. Positively charged atom or body. So this atom is neutral, but suppose extra electrons are coming, so that atom become negatively charged. If some electrons are going, so that atom becomes positively charged. Then collection of atoms are there. We have suppose a body. It can be in liquid state. It can be in solid state. It can be in gas form, gaseous state. So it is full of atoms. If large number of atoms are negatively charged, so we will say that whole body is negatively charged. For example, I'm holding a metal ball. I'm holding a metal ball. Let's say this metal ball, it is made up of iron. Suppose it is made up of iron metal ball. So you can call it conducting. So it is a conducting metal ball. I am adding electrons to it. So many electrons I have added. Somehow I have, how I am adding, that we will study separately. Somehow we are adding electrons to this metal ball. So where those electrons will go? They cannot they cannot move inside metal. They will be somewhere. They will be somewhere. So suppose that electron is near this atom. Suppose this is the atom and this is the electron. So if this electron is near that atom, so we can collectively say that electron will be attracted towards the positively charged nucleus. So this electron is part of this atom. So we'll say this atom is negatively charged. So many atoms will be there, that becomes negatively charged, and we say this metal ball is negatively charged. So we'll say the metal ball as negatively charged metal ball, negatively charged metal ball, negatively charged metal ball, because we are supplying electrons to metal ball. So they have large number of electrons. So that is known as negatively charged metal ball. What else we can do with a metal ball? Suppose this is the metal ball. What if initially it is a neutral, it is a neutral metal ball. What if you take electrons from it? This metal ball is initially neutral, means all atoms are neutral, all atoms are neutral. Now you are taking electrons from most of the atoms, maybe all atoms or most of the atoms. From most of the atoms you are taking electrons. So each atom will get positively charged, because there will be deficiency of electrons. So large number of atoms will become positively charged. So all collection of atoms, so this body becomes positively charged. So we'll call it positively charged metal ball, positively charged metal ball. So this is an example of charged body. This is charged body or charged object. It can be a liquid also. Same thing we can same type of experiment we can perform with mercury. So mercury is a liquid metal. Same type of experiment we can perform with mercury. It can be positively charged, it can be negatively charged. Or molten alloys, we can perform this experiment. It can be positively charged, it can be negatively charged. It can be some other type of material, for example thread. Thread is generally made of silk. Thread is made up of silk. So this silk cloth is there. Silk cloth. Suppose silk cloth is there. So it is made up of thread. Correct? Cloth is made up of strands of thread. The material used is silk. It is not a metal. It is a non-metal. So suppose this is a thread. This is a thread. So all atoms in this thread are neutral, but somehow you are able to add electrons to it. Somehow you are able to add electrons to it. So you will see the more atoms in this region will get negatively charged. So this type of charge body is known as localized. The charges are localized as compared to metal. Metal means if you take electrons, so through all the regions of this metallic body, you are taking out electrons. If you are adding electrons to it, so those electrons will get distributed in all the regions of this metal, but they will repel also. So ultimately they will be settled in the outer surface. Ultimately the deficiency of electrons will be settled in the outer surface. So how charges are distributed, that we'll discuss separately. But what is difference in metals and non-metals? The charges in non-metals are localized. So suppose you are adding electrons here, so that means this part of this object is not disturbed. The electrons will be settled here only, the localized, not in case of metal. So We can make non-metal also positively charged or negatively charged. Let's discuss what is a point charge. What do you mean by point charge? So some books they explain this point charge as if the volume of charged body is very less, volume of charged body is very less as compared to surrounding distances, surrounding distances, very very less. For example, this is a charged body, this is a charged body. The radius of this charged body, suppose it is spherical, so it has some radius r. If you observe this charged body from this distance, say suppose this distance is 1 meter and the radius of this charged body is say 0.3 meter. So the radius is around 30 centimeter, radius is 30 centimeter and this is 100 centimeter. The distance involved is 100 centimeter. So 100 centimeter is more than 30 centimeter, but not very large. What if I say another distance which is 1 kilometer, 1 kilometer from this charged body? Then I can consider this as a point charge because the distance involved is very large. 1 kilometer means 1000 meter, which is 1000 into 100 centimeter. That means 1 lakh. 1 lakh centimeter. So this distance is very large as compared to 0.3 meter or 30 centimeter. 1 lakh kilometer, sorry, 1 lakh centimeter is very large as compared to 30 centimeter. So for this much distance, I can call this charged body as a point charge, as a point charge. So this is one meaning of point charge. There can be multiple point charges. Suppose I have one point charge here, another point charge here. So this distance, suppose this distance is d and one point charge is here, another point charge is here. This distance is very large as compared to the diameter of this charged body. D is large, D is very large, correct? So now we are calling it as a system of particles, system of charged particles. Now if you consider this as a system and you are observing this system from very far distance, so we can consider this system of charged particles as a point charge for this point, which is at very large distance from these both point charges. So for this charge, this is a point charge because this distance is very large, and for this charge body, this charge is can be called as point charge because the distance is very large. And for this point, which is also very large distance, it is located at a very large distance from both these, so we can consider this system of charges is a point charge for this particle. So this is about point charge. Now how to denote it? What is the symbol? What is the symbol for charge And is it a physical quantity? So yes, it is a physical quantity. It is a fundamental or it is a derived quantity. It is a derived quantity. So now we are starting the introduction of electric charge. What is electric charge? So it is a physical quantity. The symbol is Q. Sometimes we denote it by small q, sometimes we will denote it by capital Q. So it has SI unit. It has SI unit of coulomb. It has SI unit of coulomb, like 1 coulomb. This is 1 coulomb. It is denoted by plus 1 C. Plus 1 C. It is a coulomb. So this is the unit of charge. Now let's go back to electron and proton. So electron and proton. So the charge on electron is 1.6 into 10 raised to minus 19 coulomb with negative sign. We consider the charge on electron as negative, and the charge on proton is 1.6 into 10 raised to minus 19 coulomb with positive sign. So we consider charge on proton as positive. So they have the same magnitudes, but the nature is opposite. Electron and proton, they have opposite nature, right? So let's do one property of charge. So electric charge is a quantity, it is a physical quantity, it is a derived physical quantity, derived physical quantity. So let's learn one concept. One concept let's learn, that is a quantization of charge. Quantization of charge. We can say it is a property of charge. It is a property of charge, like you can call it first property. It is a first property of charge. First, let's write down the formula. Q is equal to plus or minus NE. Q is equal to plus or minus NE. N is a positive integer. It can be 1, 2, 3, 4, 5 and so on. And the E is a charge on proton, which is 1.6 into 10 raised to minus 19. Suppose we have a neutral body. This is a neutral body, means total charge is 0, no charge is there, means the number of positive charges is equal to number of negative charges, or we can say number of electrons is equal to number of protons. So the total charge is 0. Now suppose you are adding 1 electron. If you are adding 1 electron to neutral body, so it will get charge of 1e. It will get charge of 1e. To the same neutral object, if you add 2 electrons, then it will get a charge of plus 2, sorry, then it will get a charge of minus 2e. Okay, here when you add 1 electron, so it will get charge of minus 1e, and when you add 2 electrons, it will get charge of minus 2e. So For a neutral body, we can add only one electron or two electron or three electron. Like the number of electrons added, it is a whole number. We cannot add half electron or one third electron. Whole electron can be added. Similarly, whole electron can be removed. So that's why we see numbers like 1, 2, 3, 4 here. What if you take out electron from neutral body? Suppose this is the neutral body. You are taking one electron from it. So this body will get a charge of plus 1e. If the same neutral body, you take two electrons, then it will get a charge of plus 2e, plus 2e. Similarly, if you take 3 electrons, so the charge on this body will become plus 3e. Again, we'll say only one electron can be taken out, two electron can be taken out, or three electron can be taken out. Half electron we cannot take out, or one third electron we cannot take out. So the number is whole. The number is whole number. So that's why we say that the charge can be minus 1e or plus 1e, minus 2e or plus 2e, minus 3e or plus 3e, or minus 4e or plus 4e. So when you combine all these numbers, so we generalize it, it becomes plus or minus Ne. So charge on any object can be plus or minus Ne. So let's do one numerical. How many electrons are taken out from neutral body? How many electrons are taken out from neutral body so that the body acquires charge of plus 1 coulomb. So because we are taking electrons from it, so there will be deficiency of electrons, so the body will get positively charged. So we will use the formula Q is equal to plus N E, and Q is 1, so 1 is equal to N E, N is equal to 1 by E, and the value of E we know it is 1.6 into 10 raised to minus 19, so this will be 10 by 16. To remove this decimal, I am writing it as 10 by 16 into 10 raised to 19, then cancel it by 2, so this is 5 by 8, 5 by 8 is 0.625, then we have 10 raised to 19. Now multiply this by 10, so one power will be decreased by 1, it will become 6.25 into 10 raised to 18, 6.25 into 10 raised to 18. So these many electrons are removed, taken out. These many electrons, 6.25 into 10 raised to 18 electrons are taken out from neutral body so that the body acquires a charge of plus 1 coulomb. Suppose I want to make 2 coulombs. So 2 times of this much electrons only for 1 coulomb. So double of this, 2 times of this will create plus 1 into 2, so that is plus 2 coulomb. So it is a huge number, it is a very big number, because we know that 1 crore is a 100 lakh, so that is 100 into 1 lakh means 5 zeros after 1. So 1 crore is 10 power 7, and this is 10 power 18. So 1 billion is 100 crore, that is 10 power 9. So 1 billion into billion, 1 billion into 1 billion, it becomes very large number, it becomes very large number. So these many electrons are taken out to make plus 1 coulomb. So plus 1 coulomb is a very large amount of charge because these many electrons are involved. It is a large number. So plus 1 coulomb is a very large amount of charge, because 6.25 into 10 raised to 18 electrons are removed from neutral body. It is not easy to do. It is something which is not easy to do because when we try to remove electron from neutral body, let's take example, we are removing 1 electron from a neutral body. Now 1 electron is removed, so 1 electron is suppose removed, so the charge on this neutral body is plus. Now suppose you are removing 1 more electron, this is the second electron to be removed, because 1 electron you have already removed. When you have removed 1 electron, the object will get plus E, charge plus E on it. Then you are removing second electron, so that second electron will experience attraction from this plus E, because the charge on this body is plus E and the charge on electron is minus E. So plus E and minus E, they will attract. So removing this electron is not easy. You have to do work. You have to exert force to remove it. Forcibly it has to be removed, forcibly, because this plus E is attracting it. Somehow suppose you have removed it. The next electron now you have to remove, that will be more difficult now. Why? Because now the charge on this object is plus 2E, and now you are removing next electron whose charge is minus E. So this minus E is experiencing attractive force from plus 2E. So this minus E is not easy to remove. You have to exert greater force now to remove it, because the attraction force is more, because previously here the charge was plus E, now here the charge is plus 2E. So as more and more electrons are removed, the required force is also more. So the required work done is also more. So that's why imagine 6.25 into 10 power 18 electrons are to be removed from a neutral body. So it is not an easy task, it is a big challenge. So plus 1 coulomb is a very large amount. So practically we don't deal with plus 1 coulomb because this much electrons are involved. So plus 1 coulomb is a very large. So uh, we make charge of millicoulomb, nanocoulomb, microcoulomb. So this 1 millicoulomb is 10 raised to minus 3 coulomb. 1 microcoulomb, 1 microcoulomb is 10 raised to minus 6 coulomb. 1 nanocoulomb is 10 raised to minus 9 coulomb. 1 picocoulomb is 10 raised to minus 12 coulomb. That is a reason, because 1 coulomb is very large. So practically we make nanocoulomb or picocoulomb or microcoulomb or millicoulomb. So that is about quantization of charge. So from here we'll continue in our next lecture. Thank you.